Can any of you explain the word pseudo? What does it mean?
There is
Okay.
like something like false.
Okay, something like false, fictitious. Okay. Right. You can't say false actually, but it's something which does not exist but feels like it exists. Okay, that is what we call pseudo and pseudo force. A force which does not exist, but we feel like there is a force that exists. Anyway, you'll understand better. Now, one of you tell me Newton's second law.
F net is equal to ma.
F net equal to ma is the mathematical form of it. Okay, tell me first law.
There an object will remain at rest if no force acts on it, and if it will remain in motion if there's no force acting on it. Unless and until there's a force acting on it, will be in the same.
So it's called the law of inertia. Basically, an object continues in its present state. It may be in a state of rest or it may be moving, but an object will continue doing that unless acted upon by a net force. Okay. And when do we say the state of motion of an object has changed? Or how do you realize that a state of motion of an object change? Which quantity tells you about the state of or change in state of motion?
Acceleration.
Acceleration. Okay. When velocity changes, you can say its state of motion has changed. An object at rest, if it starts moving, velocity goes from zero to non-zero. An object which is already moving, if it changes direction or speeds up or slows down, then also there will be a change in velocity. So based on velocity, you can tell what happens to the state of motion of an object. Okay, whether it is remaining same or changing. I'm explaining this to all of you. Okay, let's consider an object. Just a moment. Let's consider this block itself. Assume it is on the ground here. And let's say there's a person nearby. Now, with respect to ground, the block is at rest. Okay, it's not moving. It is firmly placed on the ground and it is at rest there. So its velocity of the block is zero and acceleration of the block is also zero relative to ground. Now consider this person. Somewhere nearby. Right. Now, suppose the person is at rest. Okay. How will the block appear to the person? Will it appear to be moving or with respect to that person also it will be at rest? The block is just placed on the ground. If person is at rest, what is the velocity of block with respect to person?
There's zero.
Zero only, no? Block is not moving and person is also not moving. Then the relative velocity will be zero. And suppose the person is not accelerating also. Okay, I would say if person is not accelerated, then acceleration of block with respect to person is also zero. Okay, because acceleration of the block is anyway zero. If person acceleration is 0, then the relative acceleration will be 0. Okay. Now suppose the person decides to walk to the right. Okay. Now a person initially at rest, if they start walking to the right, it means they have an acceleration this way. Suppose acceleration of the person is to the right. Let's assign some value also. Assume some 0.5 meters per second square. Okay, you can see the direction. Now one of you tell me, okay, if acceleration of person is 0.5 meters per second square to the right, I'm writing it as I cap. Then type your answers in chat, all of you, don't unmute and tell. What is the acceleration of block with respect to person now? Make it fast. It is calculated like this: acceleration of block minus acceleration of person. You all are aware of that anyway, relative velocity, relative acceleration. Just tell me how much it will be. I mean, type in the chat. I don't want only the magnitude. Acceleration is a vector quantity. Along with direction, I want. Okay, Pawan, Vanilla, your answers are correct only. Others also, make it fast. What is the acceleration of block with respect to person? Saket, how much will it be? Okay, your answer is correct. Right. So most of you have given the answer minus 0.5 I cap meters per second square. That is correct. Okay, just direct substitution will tell you that is minus 0.5 I cap. So if you make the person the reference, okay, let me redraw this situation. With respect to the person, the situation would feel like this. With respect to an object, it cannot move. You know that when you make A, some object A as a reference, in that reference frame, A will be stationary. Okay, A will be at rest. So basically, person will be at rest. And as seen by the person, it appears as if the block is going back. Do you all agree with this or not? Acceleration of block with respect to person. Is this correct or not? Aishwarya, what do you say? Does it feel like the block is going away from the person or not when the person is the observer?
Yes, sir.
So the block now has an acceleration of minus 0.5 meters per second square. Now, if it is accelerating, it means its state of motion is changing. Okay. So with respect to person, the block's state of motion is changing. Now, according to Newton's laws, what changes the state of motion of an object, or what is needed to change the state of motion of an object? You will have to answer a little quickly. Pawan, what is needed to change the state of motion of an object?
Sir, velocity.
No. State of motion marala, position gaadu. To change position, velocity is needed. To change the state of motion means to change the way it is moving. What is needed? Anyone?
Or an external force acting on it.
A net external force is needed. That is what is Newton's first law. An object continues in its state of rest or uniform motion. That is, an object continues in its present state unless acted upon by a net force. That means if a net force acts on it, its state of motion will change. Now see, this block initially was at rest. But when the person got some acceleration relative to person, the block seems to be accelerating. Means with respect to person, the block's state of motion is changing. Then there must be a force responsible for that, right? Okay, Vanilla, tell me what forces act on the block?
Normal and weight, sir.
Weight and normal. In which direction does weight act?
Downwards.
Weight acts vertically downwards. Normal force?
Upward, sir.
Upward. In which direction is it accelerating apparently?
Minus I cap dash.
Is there any force in that direction, or is there at least a component in that direction?
No, sir.
No. Okay. Hope this is clear to all of you. This is what I was telling. There is no force acting on the block horizontally. Okay. There is no force acting on the block in the backward direction, but it has an acceleration in the backward direction. Where did this come from? What
Sir,
is the
friction
source?
is also present.
Okay. Others also think about it. My question is, what is the source of this acceleration? Vanilla is saying friction. So Vanilla, why do you think friction should act backwards? Because I'm asking that because acceleration is backward and you are saying friction might be the reason. What makes friction act backward? Does the block have a tendency to slide forward?
Sir, if the surface is rough, then friction will act.
Will friction always act if surface is rough?
No,
Sir,
sir.
suppose it acts. Why should it act to the left? Why not to the right?
Sir, అంటే అది మూవ్ అవుతుంది కదా సార్ ఇంకా ఫ్రిక్షన్ కదా యాక్ట్ అవ్వాలి.
Okay, so what she is saying is because it is moving, the only explanation we can give is that friction must have been acting on it. But see, okay, let us discuss another case then. Others also think about it. What is the source of that acceleration is my question. Okay, means which force is responsible for that acceleration is my question. Just a moment. Others think about it. Any other ideas? What is the source of that acceleration? Okay, Vanilla, can you say any reason why friction should be acting to the left only? What does friction generally do?
It opposes sliding.
Opposes sliding. Now, does this block have a tendency to slide at all?
No, sir.
No. Okay. Let's consider this fellow. Now that person was moving to the right, accelerating to the right. Just a moment, let me adjust this. Let's call these persons as, okay, let that person be P itself, P for Pravas maybe. So acceleration of block with respect to P is to the left because P was accelerating to the right. Okay, like this. Now suppose there is another person, okay, let's name C, some Charan, someone. This person's actual acceleration is to the left. Now relative to that person, the block will appear to accelerate to the right. Acceleration of block with respect to C will be to the right. Vanilla, now can you tell friction is the reason and friction is acting to the left? No, because with respect to one person, the block is accelerating to the left. With respect to another person, the block is accelerating to the right. And friction cannot act in both directions simultaneously. It should either act to the left or to the right. Friction or whatever net force is there. Vanilla, yes or no?
Yes, sir.
Huh. So anyone, how can we explain these accelerations? What force is giving the block that acceleration? What force is giving the block that acceleration? Okay, see, clearly it cannot be explained, right? By considering the usual forces that we take, weight, normal force, friction, tension, we cannot explain this. Fine. So you all tell me, is this a violation of Newton's first law or not? Is the blocks, see, the block state of motion is definitely changing, because as seen by any one of these, okay, let's remove the second person. It may create some confusion. Okay, I put the second person only to show that with respect to second, it should be moving this way then. So tell me, is this a violation of Newton's first law or not? State of motion changing without net force. Rishi, what do you
Yes,
say?
sir.
Okay.
Yes, sir.
Pawan, what do you say?
Yes, sir.
Huh. Okay. So basically, when how did all this arise? The block was being observed. Okay. Block is being observed by an accelerated observer. And this is the problem. You observed from an accelerated observer, and Newton's laws are, what can you say, violated or not followed. Okay, and this is true. This always happens. There is no exception also. If the reference frame or if the observer is accelerated, then whatever the observer is observing cannot be explained in terms of Newton's laws. Okay, this kind of an observer, an accelerated observer, is called a non-inertial frame of reference. Okay, and when observing something from a non-inertial frame of reference, Newton's laws will definitely not be applicable. Okay, does that mean what all we studied till now is useless? To some extent, yes. But to make use of what we studied till now, even in such situations, we have to consider, okay, an extra force, an imaginary force. Because see, this block, on this block, there's no force acting, but it appears to be accelerating, but it is accelerating relative to that observer. Okay, so it is behaving as if some force is acting on it, because naturally acceleration comes from force only. With respect to observer, the block is accelerating, means there must be some force acting on it, or it is behaving as if some force is acting on it. So we need to imagine some force to be acting on it. So to apply Newton's laws from a non-inertial, I'm just writing Ni, frame of reference, an imaginary force called a pseudo force. That's the topic of discussion today. Must be considered to be acting on all the objects. Once you consider that force, you can apply Newton's laws, because there is a force to explain the acceleration. Okay, so after that you can apply Newton's laws. Is the idea clear to all of you why Newton's laws are violated in the first place? If the observer has some acceleration, then with respect to observer, objects will be undergoing acceleration without force acting on them. So there Newton's laws are violated. Okay, but if you still want to apply Newton's laws when observing with respect to that reference frame also, you'll have to consider an extra force to be acting. Okay. How much is that extra force, and in which direction should we put that extra force? Should we imagine that extra force? Let us discuss that. So let's assume acceleration of the person is some 0.5 meters per second square I cap. So person is accelerating to the right. Now when we observe the stone or block with respect to person, the block has an acceleration to the left. How much acceleration of block with respect to person is minus 0.5 I cap. Tell me, where did we get this number 0.5 from? Like in the acceleration of block with respect to person, how did that 0.5 come? Or tell me, what is the general formula for acceleration of block with respect to person?
AB minus AB.
Acceleration of block minus acceleration of person. From this was 0.5 meters per second square. That is how this became minus 0.5 meters per second square, right? So in the non-inertial frame of reference, means when an accelerated observer is looking at things, the other things seem to be having that much acceleration in the opposite direction. Okay, person's acceleration is 0.5 to the right, but when the person observes this block, the block's acceleration appears to be 0.5 to the left. Okay. So that 0.5 is coming from the person's acceleration. Okay, let it be. And you see the direction. Magnitude is 0.5, direction. Person's acceleration was to the right. Then in the non-inertial frame, object acceleration is to the left. Fine. Now one of you tell me, suppose this block's mass is some, say, okay, 8 kg. Its mass is 8 kg and it should get an acceleration of 0.5. How much force should act on it? For an 8 kg mass, to get an acceleration of 0.5 meters per second square, how much force should act? Saket, mass is 8 kg, required acceleration is 0.5 meter per second square. How much force should act?
Sir, 8 into 0.5.
That is 4 newtons, right? And yeah, I like the way you said 8 into 0.5. So that way we can generalize it. So generally, suppose the block's mass is m and its acceleration is a, then the net force that needs to be acting on it should be ma, right? So you need to imagine that much force to be acting on this system to explain things in terms of Newton's laws. So if you want to imagine how this block, if you want to explain how this block accelerates, then you should imagine a force to be acting like this. I'll write pseudo force as Fp, should be mass of the object multiplied with A. A came from the reference frame. The person was moving with an acceleration of 0.5. That's why the block got relative acceleration 0.5 in the backward direction. So pseudo force that you must consider to be acting on an object is mass of the object multiplied with acceleration of the non-inertial reference frame from which it is being observed. That much pseudo force you need to consider. And what about the direction? Let's make this a vector. Person was accelerating to the right. Pseudo force is acting to the left. Because in order to explain the motion with relative to the person, you need to consider a force to the left. So direction will be opposite to acceleration of the non-inertial reference frame. Okay, if you consider this much force to be acting on an object, then you will be able to explain what is happening in terms of Newton's laws. Otherwise, as such, Newton's laws are not obeyed when observing from a non-inertial frame of reference. Okay, so there's no question of applying them, but if you still want to apply, you need to imagine this force to be acting. Is the idea clear to all of you? Why there is a need to imagine a force and all? Why the force has to be ma, why it should be in the direction opposite to frame? Are all the ideas clear? Rishi, tell me, why did we conclude that pseudo force should be in a direction opposite to the acceleration of the non-inertial frame?
Sir, because when the person is moving,
Accelerating.
yeah, so it looks from the back. That's why.
Okay, when the person accelerates to the right, relatively object appears to accelerate to the left. In order to explain that acceleration, we need to consider a force to the left. So frame acceleration is to the right. The non-inertial frame of reference, that is the person, acceleration is to the right. The pseudo force is to the left. So remember, direction of pseudo force is always opposite to the acceleration of the non-inertial frame from which you are observing. Okay, Saket, tell me, what kind of a frame of reference is called a non-inertial frame? Like, how do you tell whether something is an inertial frame or a non-inertial frame?
Sir, the acceleration which is coming, even when we take acceleration to respect to something, if the object, the accelerated object is at rest, then even then when we have an acceleration, that is an acceleration from a non-inertial frame of
No,
reference.
you are explaining how things look from a non-inertial frame. But how to say that that frame is a non-inertial? Okay, wait. You said if there is acceleration without a force, then you can understand that you are seeing from a non-inertial frame. Is that what you're saying?
Yes, sir.
Okay, so basically what he's saying is if there is unexplained acceleration, then you must be seeing from a non-inertial frame. But see, while solving problems, no, you won't know that there is an unexplained acceleration. Okay, or you may not know that there is an acceleration happening there. So how you identify a non-inertial frame directly? Okay, I mentioned here, accelerated frame of reference is what you call a non-inertial frame of reference. Anything, suppose you are inside a car and you are accelerating the car, automatically you will become a non-inertial frame. Okay, because see, suppose you are sitting in the car in front of your house will be stationary. But the moment you accelerate forward, relative to you, your house goes back. How do you explain that? You'll have to imagine a force acted on the house. Okay. Anyway, so accelerated frames are called non-inertial frames. When observing from such frames of reference, Newton's laws will not be obeyed. If you still want to apply Newton's laws, which obviously we have to, okay, you can do it after considering an extra force on every object that you are observing. Suppose there was another block, on that block will also accelerate backward, no, relatively. On that block also you'll have to apply a pseudo force to explain its motion in terms of Newton's laws. So whichever object or objects you are observing, on all of them you will need to consider an extra force, an imaginary force called pseudo force to be acting. Then you can explain what is happening. Okay, let's solve some problems based on this. First, you all tell me, have you all used a weighing machine sometime?
Yes, sir.
Yes, sir.
Okay, you all must have. Fine. What does a weighing machine measure?
Our mass or weight.
Your mass or weight, which one? Both.
Weight, sir, weight.
Okay, Rishi is saying weighing machine measures weight. Anyone else?
Sir, kiloweight.
I'm not asking the unit. What is the quantity that it measures?
Weight, sir.
weight. Okay. Fine. Obviously, that's why it's called a weighing machine. It's used to check the weight. Fine. Now, my weight is, let's say, 87 kg. It's actually, I mean, to speak in terms of proper units, my weight is 87 kg weight. Okay. In layman terms or in everyday usage, we just say 87 kg. But what we mean is 87 kg weight. Those of you who were not there in the beginning of the course, remember when weight, see, weight is mg. It's a force. It's not mass. It is mass multiplied with gravity. Okay. It's a force. So when someone says their weight is so and so kg, its actual meaning is that the weight is that much kg weight. They omit this term and they just say kg, but it's actually kg weight. And what does that mean? Can one of you tell me? 87 kg weight is how much in newtons? Okay, it literally means the weight of 87 kilograms. That is mass into gravity. 870 newtons. That is my weight in SI units. Okay, in newtons, if I have to express my weight, it is 870 newtons. Fine. So remember, 1 kg weight is literally the weight of 1 kg, which is basically m into g, 1 into g, 10 newtons. Or if you want to take g as 9.8, it is 9.8 newtons. Okay. So weighing machine measures weight, you all are saying. Now my weight is 87 kg. Now tell me, if I stand beside the weighing machine and I put my hand on it, will it show my weight?
No, no, sir.
Okay, I hope you all know this. If you stand beside it and you just touch it or push it, it won't show your weight. Then is it right to say that weighing machine measures our weight?
No.
It doesn't know your mass. Okay, it can't measure your weight. So what exactly does a weighing machine measure?
The amount of force we put.
Good, good. I'm sure some of you might have tried this also. Like you press on the weighing machine, it tells you how hard you are pressing it. That's all. Okay. When you stand on a weighing machine, simply stand, no jumping and all. When a person simply stands on the weighing machine, what happens is the person's weight will be acting downwards. Weighing machine will be, or you can say, the person will be pressing the weighing machine with a force equal to the weight of the person. Okay. When person simply stands on a weighing machine, the normal force between the person and the weighing machine will be equal to weight of the person. That is how it is able to indicate the weight. But it doesn't actually measure weight. It measures the normal force. It measures how hard you are pressing it. That's all. Okay. So remember, weighing machine measures the normal force exerted on it. That's all. Okay. Now consider this situation. Suppose there's an elevator, lift. Let's say at the floor of the elevator, there is a weighing machine on the floor of the elevator. Right. Okay. Suppose a box is placed on that weighing machine. Assume the mass of the box. Okay, let's do the general derivation. Assume its mass is m. The box is placed on the weighing machine. Now you all tell me, what will be the reading shown by the weighing machine? Or is it hard to tell?
There it depends.
It depends on what?
If it's going up or down.
Okay, Rishi is saying it depends on whether the elevator is going up or down. Others, what do you think? Will the weighing machine indicate a reading of mg, or does its reading depend on the situation? Okay, for some of you, it might be hard to guess. Some of you might have studied this already. This will be there in the NCERT textbook also. But you all tell me this from your everyday experience. Rishi, don't answer. Others, you tell me. Suppose you are in an elevator. I mean, you just get into an elevator and elevator just starts moving up. You all tell me, do you feel heavier, lighter, or do you feel like you always feel? Indirectly, my question is, suppose you are simply standing on the floor, you can feel some pressure on your feet. When the elevator starts going up, do you feel any extra pressure on your feet, or do you feel the normal usual pressure itself, or do you feel lighter? That is my question.
Sir, you will feel pressure.
You'll feel some extra pressure on your feet. Okay. Aishwarya, do you agree with that or not?
Yes, sir.
Pawan?
Yes, sir.
Okay. If any of you have not particularly observed this, do it the next time you get the chance to get into an elevator. Just get inside, press some upper floor, and observe how you feel when the elevator starts going up. You will feel slightly heavier. At least for a moment, you will feel heavier. Okay. So see, the important term here is that it starts moving up. Starts moving means it is accelerating. Simply moving doesn't mean accelerating, but from rest, if it starts moving, there is acceleration. So accelerates upward, then you will feel heavier. You will feel some extra pressure on your feet. In fact, you can experience this while jumping also. So if you want to jump, what do? You slightly bend your knees, like you go down a little bit, and then you push on the floor hard. The pushes will like you push on the floor hard with your feet. The floor will in turn push you up. That is what helps you jump. So when you try to jump also, basically you are accelerating in the upward direction. And that time you observe there will be some extra pressure on your feet. Okay. Means you will feel heavier. Okay. Now you all tell me, feeling heavier means greater amount of normal force on your feet or lesser amount of normal force than usual? You're feeling heavier means there will be a greater amount of normal force than usual on your feet or lesser amount of normal force?
Sir, greater.
Greater amount of normal force. Okay, correct. Okay. Now let's consider this situation itself. Assume the elevator is accelerated upwards. Let's say the acceleration is A. There's a box inside, and let's consider two observers. Just a moment, all of you. Okay, let's put these two fellows only. Assume there's one observer outside and assume there's another observer. Where is that other person we removed? Okay. Assume there's another observer inside the elevator. Now you all tell me, okay, wait, let me put that observer, another observer. Right. Let's name them X and Y. Outside person is X. The person inside the elevator, let's say his name is Y. Elevator is accelerating upward with an acceleration A. Type your answers in chat. How much is the acceleration of box with respect to X? And how much is the acceleration of box with respect to Y? The box is simply kept on the weighing machine in the elevator, and the elevator is accelerating upward. So as seen by X, how does it appear to be accelerating? As seen by Y, how or at what rate does it appear to be accelerating is my question. If you want, you can assign a magnitude to this. Let's say 2 meters per second square. Based on that, you answer.
Sir, is person X at rest?
He's simply lifting his foot. Person is at rest. I got one answer as 2 and 0. I got another answer as 0 and 2. We'll see. Others also send your answers. Okay, 2 and 0, 2 and 0. So acceleration of box with respect to X, most of you are saying it will be 2 meter per second square upwards. That is correct. Okay. So generally, if the elevator's acceleration is A, then acceleration of box with respect to X will be A itself. Same as the elevator. At whatever rate elevator is rising up, at the same rate the box will have to rise up. Okay. And acceleration of box as seen by Y. Y is a person inside the elevator, no? Now, if the person is inside the elevator, to that person, the box will appear to be at rest. Okay. So acceleration of box with respect to Y is 0. Pawan, do you agree with this or not?
Yes, sir. Same answer అవుతుంది కానీ reverse రాసింది sir.
Okay, fine. Yusuf, what do you say? I didn't get any response from you. Okay, fine. So this is how things will appear to the observers. Fine. Aishwarya, tell me what forces act on the box? What real forces act on the box?
So weight and normal.
Weight and normal force will act. Good. Its weight is mg. And there will be a normal force acting on it. We'll discuss how much that is. Okay, now there are two observers looking at the box. Which of these observers is an inertial observer? Inertial means non-accelerated. Which observer is non-accelerated here?
Why, sir?
With respect to ground jodala.
X, sir.
Okay, X is at rest on the ground, no? So X will be an inertial frame. And along with the elevator, Y is also getting accelerated. So Y becomes a non-inertial frame of reference. Okay, X is the inertial frame of reference. Y is the non-inertial frame of reference. Now let us come down to the, or let us discuss about the inertial frame of reference itself. Okay, we know the relative accelerations with respect to X and with respect to Y. Let's apply Newton's second law. In an inertial frame, we can apply Newton's laws. We should be able to explain what is happening. So first, with respect to X, what is happening? There are two forces acting on the block and the block is accelerating upwards. Pawan, tell me, how will you apply Newton's second law, F net equal to ma, on that block with respect to ground? There are two forces acting on it and it has an acceleration. So how will you write the Newton's second law equation?
Sir, n minus mg is equals to ma.
Correct. Why did you take n minus mg? Why not mg minus n?
Sir, block is moving upwards.
See,
And
I'm
pike
telling,
equal force and all.
yeah, what you said is correct only. But I'm telling this to all of you. Stop using the word moving. Objects can move without acceleration. Okay, so moving is different, accelerating is different. Moving just requires velocity. Fine. But if you want to talk about forces, you need to consider acceleration, not velocity. So keep this point in mind always. Saying an object is moving is different. Saying an object is accelerating in a particular direction is different. So here the block is accelerated upward. So we need to take net force in the upward direction. So the proper way to apply Newton's second law would be n minus mg equal to ma. Okay, if n minus mg is ma, then the normal force would be mg plus ma. So I can write it as m times g plus a. And this is why, or this explains why we feel heavier when the elevator is accelerating upward. The normal force on the box is not mg now, it is mg plus ma, it is more than its weight. Same happens to that person Y also. The person Y is standing inside the elevator. No, when the elevator accelerates upwards, the normal force on the person's feet will be more than the actual weight of the person. That is why the person feels heavier. Okay. And see, there's a weighing machine that we have kept there. The weighing machine will blindly show you this normal force. It doesn't know your actual weight. It only knows how hard you are pressing on it or how hard something is pressing on it. So here, the weighing machine only tells you how hard the block is pressing on it. So this is the reading of the weighing machine, or reading shown by the weighing machine. Okay. That explains why we feel heavier and all. And weighing machine also will tell you that you will feel heavier. You can try it if you want. You take the weighing machine into the elevator, stand on it, then press some upper floor button. You observe the weighing machine reading. You'll see that it slightly increases.
Yeah.
Huh.
Like when I tried it, it decreases, sir, my weight.
Are you sure you press the upper floor button? or were you going down?
అంటే పైకి వెళ్ళేటప్పుడే డిక్రీజ్ అయింది సార్ వెయిట్.
See, again, simply going up is different, accelerating up is different. Let me clarify this to all of you. Suppose an elevator is moving up. I'm using the word moving, means I'm talking about its velocity. Just a moment, let me copy the diagram. You need to be careful while observing. So, yeah, forget about all these things. You can assume the box is also not present. Let's say there's a person in the elevator. Assume this was the, say, 5th floor. And next is the 6th floor. Elevator is moving up, means it has some velocity. Let's say some 2 meters per second. I don't know with what velocities actually elevators move, but let's say it was moving with 2 meters per second, and someone is waiting at the 6th floor to get into the elevator. Now you all tell me, if the elevator is going to stop at the 6th floor, it is moving with a velocity 2 meters per second. Here the velocity has to become 0. Then in which direction is the acceleration of the elevator, upward or downward? It was moving upward, but it has to stop. So in which direction is the acceleration of the elevator, upward or downward?
డౌన్వర్డ్ సార్.
Downward. Okay, ante kada. If for something to get for something to slow down, acceleration should be opposite to velocity. So it is moving up but slowing down. Okay, means the acceleration is in the downward direction. Vanilla, maybe this is what happened, and that is why you got a weight reading less than the actual weight. Or are you sure it was accelerating upward?
సార్ ఐ థింక్ ఇట్ వాస్ యాక్సలరేటింగ్ డౌన్వర్డ్ అని.
Okay, you try it later. Okay, మీకు ఇంట్లోనే ఉంది కదా, ట్రై చేయి. Fine, so just a moment. So when the elevator is accelerated upward, normal force will be more than weight of the object, and the weighing machine also will tell you that reading itself. Now you observe with respect to the person. Elevator is accelerated upward, so the person is also accelerated. Now consider that person y. With respect to y won't be able to see these accelerations and all. Okay. What is the acceleration of box with respect to y? You all said it is 0. That is correct. But see, whether x is seeing or y is seeing or some z is seeing, weighing machine reading is weighing machine reading only, no? That won't change based on which person is looking at it. Whoever looks at it, it will show you the same reading. Okay. So reading of the weighing machine will still be m into g plus a. That means the normal force is still m into g plus a. Okay. Acceleration is 0. Normal force is m into g plus a. And weight is only mg. Is it possible two unequal forces giving 0 acceleration? Is that possible? Normal force reading is shown by the weighing machine, and y also can see that the normal force is m into g plus a. The weighing machine will show that reading, and y knows that the actual weight of the box is mg. Okay. Now normal force is more than weight, but there is no acceleration. According to Newton's laws, that is not possible. So, and yeah, we know that y here is a non-inertial frame. So this is a violation of Newton's laws. Unbalanced forces, but acceleration is 0. Okay. That's a clear violation of Newton's laws. Now one of you tell me, how will the person Y be able to explain this in terms of Newton's laws? If the person Y wants to apply Newton's laws, what should the person do?
So start considering this pseudo force and then
The person, being a non-inertial frame of reference, must include an extra force or must consider an extra force to be acting on the object. Then the person will be able to explain what is happening. Okay. Now, from what we discussed earlier in this class, in which direction should pseudo force be applied?
opposite to the
Opposite.
inertial frame.
Opposite to the acceleration of the inertial, non-inertial frame. In an inertial frame, you won't apply pseudo force. Okay, non-inertial frame, right? Now, non-inertial frame is the person. Person is accelerating upward along with the elevator. So pseudo force in this case must be applied downward. I'll write it. I'll call it as FP, pseudo force. Okay. Someone else tell me, how much pseudo force should be considered on an object? What is the formula for pseudo force?
Mass into acceleration of non-inertial frame.
Mass of the object on which you are applying multiplied with acceleration of the frame from which you are observing. Okay, that much pseudo force should be considered. So in this case, pseudo force will be mass of the object on which we are applying is m. Acceleration of the frame is the acceleration of the elevator, that is a. Direction is opposite to that acceleration. Now, if you ask that person to explain things in terms of Newton's laws, he will be able to do. The normal force is m into g plus a, weight is mg, pseudo force is ma, then upward force balances downward force, then acceleration can be 0. Newton's laws are obeyed. Okay, so once the pseudo force is considered, not once the pseudo force is considered, only when pseudo force is considered, you will be able to explain things in terms of Newton's laws from a non-inertial frame of reference. Is this clear to all of you?
Yes, sir.
So when an elevator accelerates upwards, the object feels heavier. So how much weight does the object feel? mg plus a. In place of mg, or instead of mg, the object will feel mg plus a. Okay. Next case, let's say elevator accelerates downward. One of you tell me, how will the motion of the elevator be if it is accelerating downward? Like, how will you know if an elevator is accelerating downward? By looking at it, how can you tell?
There you start feeling like lesser weight.
A feeling is different. Okay, that is if you are inside the elevator. Suppose you are outside. How will you know that it is accelerating downward?
The elevator is moving down.
Simply because it is moving down, it is accelerating. Moving means velocity is in the downward direction. How can you say acceleration is downwards? How can you say
velocity in the downward direction?
It
gains velocity in the downward
gains
direction.
velocity in the downward direction? That is one possibility. Correct. It speeds up in the downward direction, then you can say its acceleration is in the downward direction. Is there any other possibility?
Sir, the relative acceleration changes.
See, you're talking technical terms. I'm saying by looking at an object, how do you say that it is accelerating downward? When you say relative acceleration changes, relative acceleration of what with respect to what changes, and how does it change? Increase, decrease, what should happen? All that you should tell. Like, see, one answer we got is that if it speeds up in the downward direction, it means it is accelerating downward. So that is like, A clear answer, no? You can just tell whether it is speeding up or slowing down. If it is speeding up downwards, that means it has downward acceleration. How else can you tell that an elevator or any object is accelerating downward?
Sir, it is slowing down in the upward direction.
Correct. Okay. See, simply you consider a ball projected upward. Gradually its speed will decrease. It is moving upward, but it is slowing down. Why? Because there is gravity acting on it in the downward direction. So that is another way to tell that an object is accelerating downward. It is moving up, but slowing down. Its speed is decreasing. That means its acceleration is in the downward direction. The other way to tell is that it is going down and speeding up. Then also you can say acceleration is downward. Okay, so there are two ways to identify if something is accelerating downward. Okay, suppose elevator starts moving in the downward direction. So you got into the elevator at some floor and you press the button to a lower floor. So it starts going down. So an object which is at rest started moving down means it accelerates down. Okay. If elevator is accelerating down, then acceleration of box with respect to the person X who is on the ground will now be minus a j cap, a in the downward direction. But with respect to Y, the box will still be on the floor of the elevator only. So the relative acceleration will still be 0 with respect to Y. Okay. Rishi, tell me, how will you apply Newton's second law on the box with respect to the person X, inertial frame?
So now will be
Hmm.
mg minus n is equal to.
Correct. Because the acceleration is downward, it will be mg minus n equal to ma. So now the normal force becomes mg minus ma, that is m into g minus a. And this is less than the actual weight of the block or box, whatever it is. And this is what the weighing machine will show you, this reading. Okay, let's say the actual weight of the box is some 60 kg weight. The weighing machine may only show you 40 kg weight or something like that, depending on the acceleration. Okay. Now let us consider the situation with respect to the person inside the elevator. Again, same thing. I don't think you will have to spend much time discussing why it happens and all. With respect to that person, the acceleration is 0, but the weighing machine reading is the weighing machine reading. We can't change that. It still shows m into g minus a. Lesser force, greater force, but acceleration is 0. That person cannot explain this in terms of Newton's laws. So Newton's laws are violated. But if that person wants to explain it in terms of Newton's laws, the person will have to consider a pseudo force to be acting on the box. Talk about that. Aishwarya, tell me, this time, in which direction should the pseudo force be applied?
Sir, upward.
Upward, because the non-inertial frame, that is the person Y, was accelerating downward along with the elevator. Pseudo force should be in a direction opposite to the acceleration of the frame. And how much? Mass of the object, acceleration of frame. Now if you consider all the upward forces together, this plus this becomes mg. The downward force is mg. Then the person will be able to tell or will be able to explain why the acceleration is 0. Okay, so only if you consider a pseudo force to be acting, you can explain things in terms of Newton's laws from a non-inertial frame of reference. And keep this point in mind. When elevator accelerates upwards, the object, any object would feel heavier. Basically, it will feel as if gravity has increased. Okay.
Sir,
Yeah, tell me.
Sir, if the acceleration of the elevator is more than g,
We'll come to that point.
then
Huh.
normal will be negative.
Can normal ever be negative?
No,
Normal is on normal force is the force with which surfaces push each other. Okay. Yeah. What she's saying is if A is greater than G, in this case itself, in the case where elevator is accelerating downward. Okay, wait, maybe I should keep all this as it is. We'll take this picture. Okay, we'll discuss that also. If acceleration of the elevator is more than G, then what will happen? Okay. If you directly use the formula n is equal to m into G minus A, then this becomes negative. If downward acceleration is more than G, this becomes negative. Okay. You are not supposed to use this here. So wherever I wrote that, I should have put a star mark actually. Conditions apply. Okay, tell me, why is the block pressing the weighing machine? Why is the block pressing the weighing machine? What is making it do that?
Or the force,
Which force?
like its mass.
Its weight, gravity. Okay. Mass is not a force. The weight with which, the gravitational pull with which it is being attracted by the earth, you call that as its weight. Yeah. By virtue of its weight, it tends to press the weighing machine. Okay. Now, if acceleration is more than g, or even if it is equal to g, we had discussed a case like this sometime before when we started laws of motion, or maybe when we started discussing applications of F net equal to ma. Okay, never mind. If there are two blocks, one kept on top of another, and both are allowed to fall freely, how much normal force will they exert on each other?
0, sir.
0. Why? Because lower block has a tendency to accelerate at the rate of g, 10 meter per second square. Upper block also is under the influence of gravity only. Gravity is what is pulling down. And due to gravity, it will also get the same acceleration 10 meter per second square. Then upper block doesn't try to go faster than the lower block. If upper block is not trying to go faster than the lower block, it will not push it. Normal force will become 0. Same thing here. The box is not pasted to the weighing machine or the floor of the elevator. It is just placed on it. Okay, it is not stuck to it. Okay. Now, if the elevator goes down with an acceleration more than or equal to g, the box cannot go down with an acceleration more than g. Okay. So what will happen? Let's take both cases. Suppose acceleration of the elevator is equal to g. Then elevator will go down with g. Weighing machine will go down with that acceleration g. The box also goes down with the same acceleration. They have no reason to push each other. In that case, normal force becomes 0. The equation also tells you the same thing, m into g minus a. If a is equal to g, the normal force becomes 0. Makes sense. Suppose acceleration is more than g. Okay, so you all should imagine this on your own and be able to comment something at least. So suppose the acceleration, downward acceleration of the elevator is more than g. Assume the weighing machine is stuck to the elevator. It is fixed on the floor of the elevator, bolted to it. So what will happen? Or first of all, elevator has ropes tied to its roof, not to the floor. Okay. And rope or a string cannot push. If there is no force pushing it down, then at max this can be under free fall and fall with an acceleration g, not more than that. Okay. But let us imagine some case where an elevator has a rope tied below it also. And some machine is pulling it down by creating a tension. Then it can go down with an acceleration more than gravity, greater than free fall. Let it go. What will pull the box down? Box will be pulled down only by gravity. No, it is not pasted or stuck to anything. So in such a situation, what will happen is the elevator will accelerate. Okay, this, let's say this is the initial position. A moment later, elevator would have gone down. Elevator would have gone down at a rate more than g, but box will be going at a rate g only. At max, it can't go faster than that. So this is what will happen. Relatively, the box will appear to rise up. And after some time, it will hit the roof of the elevator also. It is actually going down, but relatively it will appear to be going up. Why? Because the elevator is going down faster than the box, accelerating faster than the box. Vanilla, is this clear?
Yes, sir.
Others, any doubts? So in such a situation, you should not talk about normal force. You should say the box loses contact with the elevator. There won't be a normal force acting on it. After some time, when it goes and hits the roof of the elevator, there can be a normal force again. Just a moment. After some time, the situation will be like this. Now the box will feel pushed down by the roof of the elevator. Then there will be a normal force acting, and that will be acting downward. Apply Newton's laws, you can tell how much normal force should act. So the box is going down only under the influence of gravity. Elevator by some means is going down at a rate greater than that of gravity. Then relatively the box will appear to rise up. Now, how did that person stay there? What would Pegel Pothod? Elevator is connected to the rope, but person is not stuck to the floor of the elevator. No, so person will have to float. Okay, never mind. I hope you get the picture. Any other doubts? And this is true. Person will also appear to float along with the box. After some time, person will also hit the roof of the elevator. We are assuming weighing machine is bolted to the floor of the elevator. Otherwise, weighing machine will also start floating relatively. Okay. So what have we learned today? That when things are being observed from a non-inertial frame of reference, how do you say it's a non-inertial frame of reference? Accelerated frames with respect to ground. So when things are being observed from that kind of a reference frame, if you want to apply Newton's laws and explain what is happening, you will need to apply an extra force called a pseudo force. Direction of pseudo force should be opposite to the acceleration of the non-inertial frame. Magnitude of pseudo force will be mass of the object on which you are applying it, multiplied with the acceleration of the non-inertial frame. Okay. Fine. Questions based on this we'll solve in the next class. Next class will be on Wednesday. We'll continue. We'll discuss a few cases where pseudo force has to be applied and we can find out accelerations and all. After that, we'll discuss this concept of conservation of linear momentum. Okay. If you have any doubts, you can ask. Otherwise, I'll close this session.